What happened?
No idea.
Okay, all right. We're live here on YouTube and we're going to start recording. All right, thanks everyone for joining us. We have a special guest today, Dr. Mario Lavallo, I believe is his name, so he'll be joining us very shortly, but I'll just give you a quick heads up of our program right here. Share screen. Okay, so we are live streaming right now on YouTube. So this is our show. This is our lineup right here. Scott, we started off with Scott with the Planetarium Show. A little update on the Planetarium as well. He's got a live streaming on Sunday. He'll explain that more. Of course, we'll have what's up. I'll make my announcements, and then we'll have our very special presenter, Dr. Mario Lavallo, with his book. So let's, without any delays, let's get this rolling.
Hello.
All right, Scott.
Okay, great. Let me do a little screen share here, make sure that this is all working properly. Sorry, I got 25 windows open. Okay, we'll start here. Okay. Well, hi everybody, my name's Scott Young, and I work down at the Planetarium at the Manitoba Museum, which is still currently closed. Normally at this time, we would be into our Christmas season and gearing up for all of our Christmas activities, but of course, everything's online this year. One of the things that we've done every year since I was a kid was run basically a Christmas type show, and usually it's a show that sort of talks about, you know, winter solstice and why there are so many celebrations and festivals at this time of the year and why so many of them involve the theme of light. As astronomers, we're fairly familiar with the fact that you wind up with a lot of darkness at this time of the year. And then I saw an article yesterday. We all know that the Jupiter and Saturn conjunction's coming up. I'm sure Jay's going to talk about that. But I saw it called a Christmas star today. And I thought that was really interesting because, of course, the Christmas star is one of the sort of celestial stories from the Christian Bible and has a lot of sort of lore associated with it. So I thought we'd look a little bit at a couple of those things here. So let me go through here. You should all recognize this place. Here's our planet, the Earth. Yes, it is round. This is where you keep all your stuff. The Earth orbits the sun and it spins once a day. So all of these motions give us all of our familiar observable things, sun rising and setting and the seasons and all that kind of stuff. And of course the sun is the other part of that, the center of the solar system, big gravity to keep us all in place. Those two things provide a set of cycles in the sky, and ancient peoples all the way up to today recognize these things, and you can set your watch by it. You can use it as a calendar. People, in fact, have done that for thousands of years. Even before Google, there was ways to mark the sky and, keep track of the time and the seasons. And that was pretty much life and death, because if you, natural selection would take out any non-astronomers a couple thousand years ago. If you could not tell when winter was coming, you were going to die because you would not have enough food for winter. So astronomy used to be really key kind of material. This is the typical picture that is shown to explain why we have these seasons and why we have the winter solstice and the summer solstice and all that kind of stuff. It's kind of, if you already understand it, this diagram does a very good job of explaining it. But if you don't already understand it, it can be a little confusing. The idea is that as we go around the sun, the north pole of the Earth is tilted over from the orbit of from the plane of our orbit about 23.5 degrees. And that tilt doesn't wobble around like this every time we go around the sun. It does wobble, but we'll ignore that for now. It basically stays in one direction. So as we move, that pole is always pointed in the same direction. And so sometimes you wind up, oops, I went too far here. You wind up pointed towards the sun, and sometimes you get pointed away from the sun over the course of the year. Well, that explains a few of the phenomenon that we see. This is a picture from our Planetarium Show with a season of light that we used to run. And basically it shows the path of the sun across the sky in the summer solstice, that's the green dots, and on one of the equinoxes, that's the sort of reddish dots, and then at the winter solstice down at the bottom there. And so this just reinforces what we know as backyard astronomers. You know, in the summertime, the sun gets high in the sky, it's in the sky for a long time, and in the wintertime, the sun does not get very high in the sky. It's only up for a few hours, it seems, and then it gets dark again. So let's concentrate on winter solstice. Here we have the situation at winter solstice. The yellow arrows are the light from the sun. You can see the poles there, and there's the Earth rotating. Let's just worry about one location for now. Let's look at sort of the latitude of North America, somewhere in North America. Remember, even though the Earth is flat, if you were standing right here, your horizon would be this black line. You don't see the curvature of the Earth as an individual. It looks flat to us. And so the sun is coming in at a pretty shallow angle during the winter solstice. And that is the reason that we have so little light. Basically, the sun does not get very high in the sky. You can actually calculate exactly how high it'll be. It's only 16.5 degrees above the horizon for us here in Winnipeg. And as you go farther north, you get to the point where the sun does not even rise at all. Up by the North Pole there, you'll notice that the North Pole does not come into daylight at all. So you get the long periods of darkness, the long winter nights up in the north. And of course, you look down at the southern hemisphere at exactly the same time. It's the reverse situation because, you know, you've got a symmetrical kind of thing here. So this solstice is something that we've known about for, you know, thousands of years, and people have always gotten a little antsy right around now. You know, if you didn't know about orbits and you didn't know about planetary mechanics and all of that stuff, all you knew was that the sun is getting lower and it's getting colder, you would be perhaps a little frightened. And at this time of the year, basically many cultures around the world, especially those in the colder northern and northern regions, basically celebrate with some kind of light. You get, you know, putting lights up on Christmas trees, you get Christmas lights, you get the Yule log, you get Christmas candles. All of these things are basically kind of rituals designed to, you know, bring the sun back and, you know, encourage the sun to come back. And guess what? It works every year. Every single year, the sun starts to turn around, and clearly it must be because of our actions down here on the ground, right? That's the correlation, not causation situation, obviously. But it was very compelling to ancient peoples. And so the traditions that we have, like we've got Christmas coming up, it's Hanukkah today, there are, all of these things are based on this understanding of the sky from a long time ago. So, you know, the Christmas tree, if you've got lights in your Christmas tree, you're kind of following back to those early pagan ceremonies that would basically try to encourage the sun to come back. And there's nothing wrong with that. I mean, now there is one other thing, one other sort of symbol of light at this time of the year, and this is the thing that really sparked this discussion, the Christmas star. We have our planetary conjunction coming up. The Christmas star, well, I didn't even follow the article very well. I don't think it was well written, but I think one person wrote that article and it went all over the place because I've seen it a bunch of different places. So I thought I would take a look at the Christmas star and sort of see how this connection was made. Now, I will say I'm not a particularly biblical literalist. I'm not a non-believer or a believer, so feel free to take from this what you want. I'm going to focus on just the astronomical aspects of this. There's a whole science and religion talk that would get much longer than the time that I have allotted here. I'm happy to have that discussion with you at the pizza time. But if we're going to talk about the Christmas star, that's part of the nativity story of the Christian Bible. What do we know about this Christmas star? There's this Christmas card idea. There's this blazing light in the heavens, and it calls the three wise men from the east who come journeying with gifts, and they find a baby in a manger, and it's the whole story, right? Almost everything about that story is wrong, not only from a scientific point of view, but also from the biblical point of view itself as well. Do we know what year the Christmas star was in? Do we know the date, the time of the year? Do we know where it was in the sky? Do we know how bright it was? No, we literally know nothing about it. And yet it's developed over a couple thousand years into this big, beautiful beacon. You would think that if there was a giant bright star in the sky, everybody would know about it. But that's not the case. And it's not just a simple matter of going back to year zero, because the guy that came up with the calendar in the 8th century made a bunch of math errors and got all of those numbers wrong. So we can't even just use the calendar and go back and try and figure it out. So really, we're kind of very light on evidence of trying to figure out what this thing could be. The thing that we do know, though, is that it was not a big, bright beacon in the sky. And we know that because Chinese astronomers have been watching the sky for thousands of years, recording things very, very meticulously. They recorded supernovas and comets and northern lights and all sorts of stuff. They also would, ascribe significance to things. It was usually an omen, either good or bad. And they would try and forecast their future and so on, usually to do with royalty. But they did not record a big, bright, blazing beacon in the sky any time around, 1 AD or 1 BC or any time around then. There were a few comets that were discovered, and those are kind of unusual. But you know what? Comets were always seen as evil omens. So I don't think that really fits the whole story that we're looking at. That's not the kind of thing that would make the three wise men, get up and journey across the way to give gifts to someone. All we know about these three wise men are their names. We don't know where they're from. We don't know anything about them other than a couple of lines in one of the Gospels of the Bible. We think they were probably astrologers, and when they came looking for the baby Jesus, they came to King Herod, who was the guy in charge in the Middle East there, and they said, "We've come to where's this King of the Jews, because we've seen the star." And he's like, huh? He didn't know anything about it. Now, Herod had astrologers. They should have seen this sign if it was something that was obvious. So the current thinking, sort of archaeologically and scientifically, is that there was something that might have happened in the sky that only this particular sect of people knew about. And so that is kind of where my explorations started. So at this point, I'm just going to switch over to Stellarium. This is a great free piece of software. I actually have to stop and then share again. Where are we? There we are. This is a great free piece of software. You can download it, and it basically simulates everything in the night sky, the planets, all that stuff. And you can fast forward and rewind through time. And so I've rewound it. In the upper left, you might be able to see we're at -2, -7, -15. That's the year, month, and date. It doesn't handle years before 1 AD very well. So I'll just tell you that this is basically 3 BC. And there are a number of potential planetary groupings that have been sort of tagged as the one that might be related to this story. I'm going to focus on one that involves the planet Jupiter. So what I've done here is I've got Jupiter and the Sun, and they're sort of right next to each other in the summer of 3 BC, and we're just going to fast forward through time here. And as we I wanted to turn on the trails here. Let me turn on our trails so that we can see Jupiter. There we go. This really is a wonderful piece of software. And like I say, because it's free, it's pretty nice to use. So in the late summer of 3 BC, there was a planetary conjunction that was pretty interesting. It involved the planet Jupiter and Venus, and the two of them came very close to each other. Oops, I went a little too far there. There we go. They were about 3 degrees apart, which is a nice grouping, the 2 brightest planets, and they happen to be in the constellation of Leo. That's the kind of information that we would talk about if we were going to go and see the conjunction coming up. To the astrologers a couple thousand years ago, though, there was all sorts of significance of which planet was related to what and which constellations was related to what. And so it turns out that the planet Jupiter was sort of the king of the planets, and Leo was a constellation that was associated with the Jews. And so you have this king planet joining the goddess of love, or the planet of beauty, in the constellation of the Jews. Well, that sounds like something might be going on. So these astrologers would sort of start watching that part of the sky. And as they watched, they would see more things that would probably reinforce what they had already decided. For example, Venus starts to move away there, but as we go in farther, Jupiter comes right up to Regulus and has a really nice grouping with Regulus, only a degree apart or so. So you've got the king planet and the king star right next to each other in the constellation of related to the Jewish people. So that's the...
We're not seeing your screen.
You're not seeing my screen?
Yeah.
Well, that is really lame. It says you're seeing my screen.
There we go. We see something now.
It just came on.
Okay. Well. Okay, so just give me a second here so I can move a couple of windows around so that we can make sure you see everything that you're supposed to see. Okay, I'm going to stop and reshare it just so that it appears properly. It says my screen sharing is paused. That should not be happening.
It was working there a minute ago.
Yeah. Okay, let me try and share it one more time here. Now my share has gone away. There we go. Okay. Share. Okay, for whatever reason, it's not sharing Stellarium properly, even though it worked earlier today. The long story short is that basically in 3 and 2 BC, you wind up with Jupiter passing Regulus and then retrograding, passing Regulus again, and then going back to its normal motion, passing Regulus 3 times. So you get a triple conjunction of the king star and the king planet. That's the kind of astrological thing that would have been a huge deal, and yet almost nobody else would have noticed it. I mean, most people don't notice Venus. If you tell them that you can go see Venus in the morning right now, most of them don't know what you're talking about. It was the same thing back then. So these wise men might have known it, the astrologers, but the rest of the folks were kind of oblivious. And then, if that wasn't enough, a little bit later, in about May of 2 BC, Venus and Jupiter were in conjunction again, but they were so close that you would not have been able to split the two of them with your eye. I'm going to see if I can do this one more time here. Share screen. No, that's my PowerPoint. Oh, that's really unfortunate. No, it's just not going to take it. So anyway, the Jupiter and Saturn, Jupiter and Venus were about 1 arc minute apart. That's center to center, though. Jupiter is almost an arc minute across, and Venus was pretty big as well. And so you wind up with this beacon in the sky that would have been pretty darn impressive. In fact, from the Middle East, the two planets' disks almost occult each other. They're almost overlapping. So for me, it was like, okay, that's kind of cool. I mean, I'm not sure that I have explained anything to anyone's satisfaction, obviously, but it's kind of neat to know that the clockwork of the heavens that we know about actually can explain some of these statements made from long ago and so on. So whether there's, any kind of miraculous thing or not, the idea of the miracle of the universe that already exists is there. And it really makes it so that when I look at this planetary conjunction that we're seeing this week, these next couple of weeks, I'm trying to look at it from that point of view of what would I think if I didn't know what was going on here. It's an interesting way when you're observing things. It's nice to sort of put away all of our scientific knowledge and just sort of look at it as a person and imagine what it must have been like to see these things without any kind of explanation. The wise men were doing their best to try and explain things in the heaven and how it all worked. We look back now and we say, well, astrology, that's not something that we should put any faith into. I wonder in 2,000 years what people are going to be saying about the ideas that we have. Of course, we think we've got it right. Well, they thought that then. And it'll be interesting to see what time has to say about the way we look at our universe. I will post these images to the forums and the Facebook page, but I do want to give you one more image here that I'll share from the PowerPoint because that was working. And let's see here. Can you see that?
Yes, we can.
Okay, good. We do have upcoming events at the Planetarium. Of course, they're all live streamed. This Sunday from 7 to 9, we'll be doing live all-sky camera for the Geminid meteors. And I know that Sylvia is going to be doing something with parks tomorrow, the night before, to get everybody prepped. Right now, the weather looks like Sunday night might be clear and cold. So if you decide not to dress up and go outside, you can join me online and watch the all-sky camera. We're also going to be online for the 21st for Jupiter and Saturn. Should be able to fit both of them in the telescopic field of view, and that'll be cool. And then, if you're interested in seeing some of the visuals you didn't see, or talking a little bit more about the whole Christmas star, we have a special planetarium show that's brand new to us that we're going to be running online, along with a Q&A kind of thing coming up on the 23rd. So lots of stuff going on at the planetarium, despite the fact that we're closed. And I did want to say thank you to the various people that have recently either dropped me an email of support or things like that, or folks that have come out and helped out the planetarium. It's really gratifying to see the support out there, and I'm looking forward to the day that we can reopen the doors and get you all down to take a look at our dome again. We've got a bunch of shows that are just waiting to come out for you. So I'll leave it at that. If anybody has any questions. Alas, none of the screen went to you.
It doesn't look like we have any questions here.
Yeah. Okay, great. I'll drop it back to you then.
Okay, thank you, Scott. That was great. Okay, so next we have Jay for What's Up in the Night Sky. Jay, you want to take over?
And do. Okay. Well, in honor of the sun coming back into activity, I decided I'd throw up an old aurora picture from the Sprucewood Star Party a few years ago. Speak to me, oh great computer. There we go. So the big story, Scott's already alluded to it, conjunction of Jupiter and Saturn on December the 21st. Here I've made a couple of pictures together showing the evolution on the left side from December 17, 18, 19 and 20, 21, 22 on the right hand side. And you can see how the two planets pass each other. Here we have them on the 17th, and you can get a relative idea of the distance by the size of the disk of Jupiter here. And then a day later, noticeably closer. Of course, they're both moving, so the star, red star here, Jupiter's gone past it. And so on and so forth until we get up almost at the closest point in the 20th. And then we get to the 21st. This is our evening sky at about 5:30 in the evening. And you can see that they've actually passed the point of closest approach. And the next day they're drawing rapidly away. So it's going to be a pretty nice treat for at least those 3 days from the 20th to the 22nd. And I think well worth the trouble to go out and look at visually or with binoculars. Here's what it looks like close up. And you can see here, I've marked the moons of Jupiter, Callisto across to Europa on the other side. And you can see that the separation from Callisto at the most distant point is about equal to the separation from the two planets. So essentially, they are passing each other sort of in the same time scale as Jupiter's moons. So a little bit of magnification, even more than binoculars, will help put that in perspective. For reference, here's where they were July 16, 1623, the last time they were this close, and in fact, a little bit closer. View from Winnipeg. Haven't seen any references to that in any of the literature from this continent. And of course, there's lots of excitement about this, as you see. I haven't quite deciphered all of this and the many pages of writing that came with this graph, but it seems like somebody's pretty excited about this event. And I see a few things about the end of the world and various wars and pestilences and things like that. So we won't worry too much about that. Planets, Mercury's behind the sun now, coming out from behind it into the evening sky. It's low down, not going to be a really favorable appearance of Mercury for us. Venus, pretty easy to see in the morning, but it is sliding down toward the sun and becoming a little less easy to see, mostly because it's probably behind stuff that's in your view of the horizon, unless you've got a pretty low horizon. Mars, we're all familiar with that. It's high in the south, gradually decreasing in size. In January, it's going to be very close to Uranus. So that will be an interesting little event to watch if you want to pull out the telescope. January observing is usually a little difficult. Jupiter and Saturn, well, they're low in the southwest. We've covered them off. Uranus is high at sunset and up most of the night. And Neptune is moving toward the sunset. It'll still be up in January, but it'll be creeping down pretty close to the sunset twilight and becomes much less visible in a telescope. The sun, you can see in the graph here in the lower right that the sun has had a sudden jump in sunspot activity. The picture there on the left is the picture from this morning showing only one sunspot, but I'm beginning to wonder if we're going to get a fairly active sunspot cycle 25. But we'll be seeing auroral activity increasing, and even recently in the last few days, the auroral oval has been very, very broad, and probably if we got some decent skies, there would have been some nice aurora. I'm looking forward to our 3 to 4 times a week aurora coming up in another couple of years. We have Comet Atlas still with us, magnitude 8, a little bit fainter than that, and it's moved past, you remember last month I talked about it passing through Orion. It's now in Auriga and be passing through that, getting a little higher in the sky, but as you can see from the graph, it's going to be dropping down into the 9th and 10th magnitude. You'll need a telescope or a bit of a time exposure and a camera to see it. 2 meteor showers. The Geminids are peaking Sunday, Monday night, and the weather does look good, as Scott was saying, at least in some of the models. This is a pretty active shower at about 50 per hour with some increases. The nice thing about it, it's a new moon, in contrast to the quadrantids on January 3rd, which comes with a pretty close to a full moon. And it's a short peak, so it's about half the strength of the Geminids, but in much less favorable circumstances. The Geminids, this is something I've showed you before. it has had a ZHR zenith hourly rate of 150. And the nice thing about it is the last point, that it seems to be good at producing long fireballs, which are the best ones to photograph and to watch. Some pretty pictures. Again, the conjunction of the moon, which you can see here. The moon is a very thin crescent, and these are both low on the horizon. That's on the 16th. 23rd, moon passes under Mars. Nothing particularly exciting about that. January 10th starts to look kind of interesting. You see a diagram up here in the lower right, and they form a nice triangle in the evening sky. And then January 11th, another nice conjunction, but this one's pretty low, and they're not really very far above the horizon. So it probably will be a lucky person that gets to have a look at that one. And here we are with the cat, and I'm done.
Sorry about that. I had it mute there for a second there. Okay, so thank you, Jay. That was nice. Now I'll be doing my announcements, Dr. Mario. So if I'm going to okay, can everyone see that? Okay, great. Okay, so this is our today's lineup for today. We got very special guests, Dr. Mario Lovaio, I believe that's how you say his name, for joining us. So we'll get started right now. Today, I'm going to try something a little different. Oh, there we go. Okay, sorry, there's some technical difficulties here. I have too many screens here. Sorry about that. Okay, so we're starting live. Today we're going to be streaming live to YouTube, something I came up with. It seems to work. I hope it's also going to be recording too at the same time. So this is something I thought would be quite nice for the general public to have access to. Again, we just heard today, especially from work, that as of January 8th, the restriction has been extended to January the 8th. So we're still in the second wave. It was officially announced on November the 10th. So again, the calendars will be mailed out. The Lunar Scope program is suspended. And of course, Langley is going to be closed until further notice. We do have something very special tomorrow. Scott did mention about it. The Manitoba Parks has approached Sylvia and Jerry for this outreach material starting tomorrow. And maybe once every month that there will be a presentation from the RASC members to do. Thanks to Jerry and Sylvia. The show is tomorrow. If you want more information, you have to register first. You just have to go to our forum or to Facebook to register. So again, it's tomorrow at 6:30, and the topic is about Gemini meteor shower and how they occur. It's a program that the Manitoba Parks has started. So congratulations, Jerry and Sylvia. I think that's great. That will keep the public active, and of course, it will promote the club. We do have a couple of giveaways, especially right now. We have 2 telescopes, beginner telescopes, to be given away to the members. Each winner will also receive a 1-year membership and an invitation to attend the star party for next year. How do you enter? You got to have your child write a 1-page essay of what I would like to do with the telescope. The full contest rules You can see it on the forum on our webpage. And of course, the deadline is going to be on December the 16th at 6 p.m. Just send your entries to president@winnipeg.rasc.ca, and the council is going to be judging it, and we'll announce the winners after that. Here are the contents rules. It's a little much here. I'm not going to go through all of it, but again, the deadline is Wednesday, December the 16th. This judge decision is final. Okay, the other membership that we have a giveaway, and we talked about it at our last council member. And of course, this is a good gesture and support of our locals here. We'll be purchasing some Manitoba Museum membership and Old Comic Marsh. And these will be given away to the members, or raffle up to the members. Of course, there also will be some memberships too. But if you have already a membership, you may want to pass it on to other people. Again, more rules. You can find out more about on our website, in our forum. The draw is open to all members in good standing orders, and winners will be published on the forum and the Wincentric. All right, so again, we're trying to support our local economy here. So everyone, good luck with that. Of course, I have to mention again about the calendars too. We still have lots. I think we have about 10 calendars, 10, 13 calendars left, I believe. Most of them are here at my house right now. So please, we still have calendars to give out. Unfortunately, we're going to have to be mailed out because of COVID-19. Unfortunately, there's no way around it. If you want to contact Abdul, this is his home address. He'll be mailing out the calendars to you once we receive the check. All right. Facebook, again, I like to mention about the Facebook is still pretty active. And of course, it posts a lot of the events, including the event that's happening tomorrow. Of course, the event is also posted on our website in the forum. It's a great way to keep in contact. I'm going to skip that one. Of course, Galileo Observatory. If you're new to the members, I'm the director of Glen Lee. If you got any questions, please feel free to ask any questions. Again, you can contact me.
Brian?
Yes?
We're getting comments here that people are only seeing your the PowerPoint, like the menu version, not the slideshow.
Oh, really?
So, yeah, so they've been looking at the first slide.
All right.
Sorry, I just noticed that.
I'm going to do something different. Okay, I thought this was going to work. Okay.
So say we all.
How's that?
There you go.
Okay,
Now
we can see it
cycle
now?
through. There, yep, now you're good.
Okay, sorry guys, I don't know what happened. I have two screens going. I thought it would make it easier for me so I can see the post of the questions and answers there. Again, you know, we're all kind of new here. So code red, for historical purposes, I want to mention about this. Again, the Lawrence Scope program is suspended and Glen Lee is closed for till we get it established. Okay, the Manitoba Parks Astro webinar. Again, I want to thank Jerry and Sylvia, the Manitoba Parks at Port Sylvia. It's a great way to keep the people engaged. Of course, this is what Sylvia's posted. I hope she's okay with it. But here it is, the seminar. You have to register first. Of course, you can go to our Facebook account or our forum and fill the registration and see the program tomorrow. So it looks like a really good program. Okay, again, I'm going to mention about the telescopes giveaway. There are 2 beginner telescopes, and each winner will receive 1 year membership. Membership. Again, you can check out our forum or our Facebook for more details to see the full contest rules. The deadline again is Wednesday, December the 16th at 6 p.m. All entries will be sent to the president at winnipeg.rasc.ca. And here's the full contest rules. Again, they'll be posted on the forum for you. All right, we'll move on. The membership giveaway, as I mentioned before, we have memberships that can be given away to it's a good gesture and support our museum and Old Comic Marsh. And of course, it'll be raffled off to members. Also, too, we'll be raffling off some memberships too for the RSC. But in good gesture, it would be nice to pass on to other people or you already have a membership. You might want to donate to other members. Okay, so again, good luck to everyone to it. All right, again, calendars. I'm just going to ruffle through this. Okay, again, if you want to order some more calendars, we have 10 to 13 left already, so please contact Abdul for it. Of course, we have our Facebook account. Again, it's a great way to keep in contact during this COVID-19. And of course, we have more than 103 active members. And I really like it because it's a great way to show your pictures and upcoming events. Okay, again, also too, we have our websites too. I'm going to skip this. Galileo Observatory, of course, is canceled till further notice until this COVID-19. It'll probably be a while too. So I don't think it'll be anytime soon. I'm hoping to do some remote programs at Glen Lee. Okay, elections. We have elections coming up next month. The motion was passed just recently. The council members are going to be extended to 6 positions now. Of course, we have our virtual Boston Pizza. Everyone's welcome to it. So because it's COVID-19, this is the best way we can come up with to kind of keep it together. So bring your beer, bring your pizza, and let's have some fun. All right, I do want to mention about the book that Dr. Mario has it's been published recently. I did check out the Washington Post. It's been reviewed by the Washington Post. It's been 5 out of 5 stars. And of course, I did check. You can purchase this book online. The book is Galileo's and the Science of Deniers. So it's a 5 out of star book. And of course, Dr. Mario will talk more about it. So that's all I want to say now for my announcements. So stay safe, stay healthy, and wear a mask. All right. So what is the time right now? Okay, we're running a bit late. Okay, I'm going to stop sharing. And Dr. Mario, if you would be so kind.
Yeah, I'll start sharing and okay, so I'm going to talk about this book, Galileo and the Science Deniers, appeared a few months ago. The Washington Post just actually chose it as one of the notable books of the year. So did Symmetry Magazine and Science News also. So anyhow, this is the book, just in case you want to see the book rather than the slide. So let me start. I start by the fact that to mention that Galileo, of course, is one of those larger than life heroes of our intellectual history. So the first thing I did was, to take, like sometimes you would take a bunch of photographs and you throw them one on top of the other that you see. So here are a few of those. This is the very earliest portrait we know of Galileo. It was done by an unknown Tuscan artist. Galileo was here probably in his 30s or thereabouts. Here he was already in his 40s, and this is attributed to the son of the famous painter Jacopo Tintoretto, who was a painter himself, but it's not absolutely sure that it's that. Of course, that's the best known portrait of Galileo. It was done by Sustermans. It's the Uffizi Gallery in Florence, in Italy. He's holding a telescope here. There are many other paintings showing Galileo in various capacities. Here, he's demonstrating his telescope to the Doge of Venice. But he was so well known that, he made it even into cartoons. This is a cartoon painted the last century, showing Galileo demonstrating to people from the Inquisition his telescopes and his findings. And he made it even into, things like pop art. Pop artists, took a portrait of Galileo and made it into this pop art thing. And, when I write about people, I like to go to the place where they lived and worked. So in this case, I was lucky enough to be the guest of the Galileo Museum in Florence for a while. And as I was walking the streets of Florence, I discovered that even a graffiti artist painted Galileo on one of the walls of the buildings in Florence. This is how well known he is within this city. But it's not just paintings. Google devoted one of their famous doodles to the invention of the telescope. And there is a play by the famous playwright Bertolt Brecht, which is called The Life of Galileo. And there is even an opera by Philip Glass called Galileo. where actually here you show him doing one of his experiments with pendulums and things like that. So all of this is very nice. And Galileo is so well known that there are many stories about him, and some of those stories are really no more than myths. And let me start with the myths, but then go to the actual discoveries that he made. So the first story is related to this particular lamp, which is hanging in the cathedral in Pisa. Galileo started his studies at Pisa. Well, he was registered to study medicine, but very quickly he didn't like that and changed instead to studying mathematics. The story that comes from Viviani, who was Galileo's student and first biographer, is that the young Galileo, 19-year-old, watched this lamp swing from side to side, and by measuring his heartbeats, he realized that the period of the swing is constant, and Viviani tells us that Galileo used this fact to develop a device to measure the pulse rate of humans. The reason that we kind of doubt that this story is correct is, first of all, when Galileo tells us that this happened, this lamp wasn't even installed yet in the cathedral. It was only installed 4 years later. Now, it's possible, of course, that there was another lamp there, and there are paintings showing even the young Galileo here, you know, looking at the lamp and so on. But he surely never invented that pulse measuring machine, because another person invented that, and Galileo, who was usually very aggressive when somebody tried to take credit from him, didn't say a word. So it probably is just a story. A second story that many people have heard is that Galileo dropped balls of different weight from the Leaning Tower of Pisa. Now, you know, there is no question that Galileo dropped balls of different weights. That he actually describes extensively in his writings, because he wanted to study free fall, and especially he objected to what Aristotle taught us, which was that a heavier ball falls faster than a lighter ball, and in fact that they fall in proportion to their relative weights. Galileo, using a very clever thought experiment, claimed that no, balls of different weights fall exactly at the same rate and the same speed. And if there is a difference, it only has to do with air resistance and nothing to do with free fall. But there is no evidence that he ever did this from the Leaning Tower of Pisa. He did drop balls, but not from the Leaning Tower. This story is still very well known. In this particular painting, Galileo is showing even dropping the balls in the presence of the Grand Duke, which certainly didn't happen. I mean, Viviani didn't even write that that's what happened. Of course, the best known story about Galileo is the fact that after being convicted by the Inquisition, and I will come back to this, the whole story of his trial and so on, that he got up from his knees after abjuring and all that, and stamped his foot and said, and yet it moves, meaning the earth, because you know, part of what he was taken to trial for had to do with the fact that, unlike in the Aristotelian and Ptolemaic old model in which everything revolved around the earth, he adopted the Copernican model in which the earth and all the other planets revolved around the sun. So the story is that, you know, after being convicted and all that, he declared, and yet it moves. Of course, not in English, he declared it in Italian, saying eppur si muove, which means and yet it moves. I spent an entire year trying to research this particular story. The story, you see, in print, this story appears for the first time more than 100 years after Galileo's death, which that would not have made it very, very reliable. But there was, in 1911, a certain Belgian gentleman who claimed that he owned the painting, which was essentially identical to the painting you see before you, which was painted only 2 years after Galileo's death. And that painting, if you look at the wall there, it shows, you see on the right-hand side here, it shows a drawing of the Earth moving around the sun, and underneath it, the words "Eppur si muove." Now, many science historians took that to say, look, if this story was known already just 2 years after Galileo's death, then it probably was correct. Of course, nobody believed it, said it to the Inquisition, but he maybe said it to a friend or to somebody else. Well, I'll make a very long story short. I actually published a whole article about this in addition to the book, and discovered that the painting that Belgian gentleman that claimed he had was actually almost certainly a copy of this painting that you see here, which was only painted in the middle of the 19th century. So that leaves the first appearance of this motto to only more than 100 years after Galileo's death. And as a result, it's almost certainly apocryphal. Now, having said this, I will say that there is no doubt, and we know that Galileo thought that way. He was indeed very annoyed by having been put on trial, was very, very upset with the Inquisition and all the people for the rest of his life. And the motto itself, and yet it moves, remains to this very day as an intellectual, a sign of intellectual defiance, saying, in spite of what you believe, these are the facts, which actually I feel like saying today many times to many people, including at very high places, some people in the US at least. Now, having told you about the myths, how about some actual discoveries? So Galileo made very, very important discoveries in mechanics. I already mentioned the fact about the free falling balls, but you see, at the time of Galileo, there were no good time measuring devices. There were no good clocks. And if you measure free fall from not a too high place, the difference in the times of fall, can be too short to be measured accurately. So Galileo had this fantastic idea of, instead of letting the bodies fall, using inclined planes, because if he makes the angle of the inclined plane small enough, then the balls roll much more slowly. So he basically diluted gravity, if you like, and made the motion much slower. And thus he was able to measure things much more accurately. And by doing this, he discovered the very first, mathematical law of mechanics. Namely, he discovered that in free fall, basically bodies cover a distance that is proportional to the square of the time that they fall. So for example, if one ball falls for 1 second, another falls for 3 seconds, then the ball that falls for 3 seconds will cover a distance that's 9 times 3 squared, more than the distance covered by the one that falls 1 second. So this was a very, very important mathematical law in mechanics. He did something even more interesting, which is by allowing the balls to roll down a plane and then fly in the air. And by doing this many times, he was able to determine the trajectory of projectiles in the air. And by doing this many times, he discovered that the trajectory described by projectiles is actually a curve known since antiquity, namely a parabola. So Galileo showed that projectiles move along parabolic orbits. And of course, both of these things helped Newton later to formulate his laws of motion. Now, Galileo's most important discoveries were, of course, done in astronomy, and they were done with telescopes. Now, some people think that Galileo invented the telescope. He didn't. The telescope was invented in the Netherlands, but as soon as Galileo heard about this, he started constructing his own telescopes. And these are the 2 remaining original telescopes of Galileo. They are, again, I saw them, they are in the Galileo Museum in Florence. He constructed his first telescopes by using organ pipes. and then putting lenses at the two sides. And he polished his own lenses. And he became very good at that, so that the telescopes that were available at the time usually had a power like 4 or thereabouts. But he very quickly managed to manufacture telescopes that had a power of more than 20. So he had much better telescopes. Like I said, he polished his own lenses. This is one of his original lenses here at the center of this very ornate frame, also at the Galileo Museum. Now, once he had the telescope, I mean, he could have done all kinds of things with it. He could have spied on his neighbors, but instead he decided to look at the heavens. And the first thing he looked at was the moon. And here is something that is very interesting, because which is sometimes being ignored for people who describe Galileo. So these are Galileo's own drawings of the moon. These are wash drawings on the left and etching on the right. And the thing is the following. You see, at the same time that Galileo was observing the moon with a telescope, Harriot, who was a British mathematician and astronomer, was also observing the moon. And if you look at the drawings that Harriot did of the moon, you know, they just look like some squiggles, and you cannot even tell what it is you are looking at. Neither could Harriot himself tell what he was looking at. But Galileo, because he actually studied as an artist, he actually studied drawing professionally and also studied light and shadow. He understood what he was watching, and he draws this extremely rugged surface of the moon, you know, with craters and mountains and all that. And for example, if you look at the left-hand side, but the bottom right drawing, the one that's marked with the number 3, you will see that in the unilluminated parts of the moon, you see these points of light. And Galileo understood that those points of light were actually the tops of mountains, which were illuminated. And then the light, you know, started creeping down the mountain. So basically, Galileo used his artistic training to actually amplify and understand the science that he was doing. Now, of course, we know today how the moon really looks because we landed on it. This is a famous picture called Earthrise, which was actually taken by astronaut Bill Anders from orbit around the moon. And you, of course, can see the lunar surfaces. You can see hills there and some craters and so on, and that's how it is. Now, another astronaut, David Scott, did a famous experiment on the moon, and I'm going to show you that now.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Mr. Galileo was correct in his findings.
So, of course, on the moon, where there is no atmosphere, then no air resistance, and then he confirmed very nicely Galileo's idea that objects in free fall at precisely the same rate. After that, Galileo turned his telescope to Jupiter. And this is the very first document which shows what he found. This is at the bottom half of a letter that he wrote to the Doge of Venice. And you can see there that, you know, we discovered, of course, the 4 satellites of Jupiter. He sometimes saw the 4 on one side, sometimes on the other side, sometimes there were 2 here, 1 there, 3 here, 1 there, and so on. So basically discovered the moons, 4 moons of Jupiter. Now, this was an extraordinarily important discovery. Why? Well, first of all, it was the first object new objects found in the solar system since antiquity. That was first. Second, the people who objected to the Copernican model, in which, you know, the Earth was supposed to be just another planet revolving around the sun. One of their objections said, well, if the Earth is just another planet, how come that only the Earth has a moon and no other planet has a moon? Well, here was Jupiter, and it had not just one moon, but 4. So that removed that objection. A second objection was that they were saying, how can the Earth move around the sun and not lose its moon? Well, here was Jupiter, and it was revolving around something, choose the Earth or the sun, but it wasn't moving, losing 4 moons. So with this observation, Galileo managed to, you know, remove 2 of the major objections to the Copernican model. Not that many people know, but, you know, you are all they're amateur astronomers, that Galileo was the first person to detect the planet Neptune. It's the object that's on the left side here. It detected it in 1612. As you probably know, Neptune was only discovered in the middle of the 19th century. Galileo did not identify it as a planet. His observations weren't precise enough to see it move, but he did detect the planet already in 1612. One of his most important discoveries was the phases of the planet Venus. You see, the thing is the following. Venus is basically always between the Earth and the Sun. And if it is orbiting the Sun and not the Earth, then it should show phases like this, like when it is the farthest from Earth, as in the top of this diagram, it should look the smallest and fully illuminated. When it is the closest to Earth, as in the bottom of this diagram, it should look the largest and unilluminated. And in between, it should show phases just like the moon. Galileo actually showed this entire set of phases, and by this showed that Venus was actually orbiting the Sun and not the Earth. So, which again, you know, went a long way towards the Copernican model. I do need to mention to you, especially because you're amateur astronomers, that Galileo did not manage to fully refute a model that was due to Tycho Brahe, which claimed that, you see, he realized that the Ptolemaic model had problems, but didn't quite want to get away from a central Earth. So basically he came up with this hybrid model in which all the other planets revolved around the Sun, but the Sun itself revolved around the Earth. Galileo's observations could not refute this particular model, but Galileo never liked this model. It looked to him as if it had, you know, too many moving parts. And of course, it turned out to be correct. This is not a picture from Galileo's time. This is, of course, from now, but it shows the Milky Way. When Galileo turned his telescope to the Milky Way, suddenly this thing which looked like almost like a continuous band of light to other people broke up into hundreds of stars, which he saw, and stars of different brightnesses and so on. And so he basically, you know, if you like, this was the first observation, I would say, of a kind of modern astrophysics. I mean, outside the solar system, if you like, you know, really into the Milky Way. I want to move now to a slightly different topic because it's so important, again, for today. In England, there was this chemist and author, C.P. Snow, and he noticed that from about the 1930s and onward, people who were in the literary circles and humanists basically started calling themselves the intellectuals while excluding scientists from this definition. And in particular, they were actually, they were scorning scientists because, they said that, they are so illiterate, they don't know much about literature and the arts and so on. While at the same time, C.P. Snow noticed, these so-called intellectuals knew almost nothing about the sciences. He tried asking them what is acceleration, what is mass, and so on, and was amazed to discover that they don't even know that. So he wrote this book in the 1950s, The Two Cultures, basically describing that a schism has developed between the humanities and the sciences. Now, today, some people think that that schism still exists or even became larger. Others say that, maybe, things have become a little bit better. My point is that Galileo himself would not have even understood what C.P. Snow is talking about. You see, he grew up in the late Renaissance. And with all this beauty surrounding him, in Florence, the old bridge here on one side, the other on the other, and this beauty. And he learned the humanities, even before he actually studied mathematics and science. So, for example, at age 24 already, he gave to the Florentine Academy 2 lectures on the location and structure of hell, of the inferno in Dante's Divine Comedy. So he knew Dante, he knew entire passages by heart, which he could cite. And, he gave these 2 lectures on Dante's Inferno. He could cite other poets, Ariosto was one that he particularly liked. He even wrote a whole essay comparing Ariosto to another poet, Tasso. He thought that Ariosto was far superior to Tasso, and so on. And not only that, not just literature. I already showed you that he knew how to draw and paint, and some great painters were his personal friends. In particular, the famous painter Cigoli was his friend, even participated in observations with him. And Cigoli painted this particular dome in Santa Maria Maggiore, which is in Rome. And I want to draw your attention to the Virgin here, which is standing on the moon. And look at the moon. This is the moon that Cigoli painted. He painted the moon of Galileo, the moon that Galileo saw through his telescope with blemishes and craters and things. Before that, when painters were painting this scene, they were painting a pristine, perfect moon, with absolutely no blemishes. Galileo, changed this entire concept and changed it into the fact that this was of crucial importance, because before that, the Aristotelian theory was that, everything on earth can be corrupt and can die, but everything in the heavens was supposed to be perfect and made of this quintessence and, and so on. And Galileo showed that, no, the surface of the moon is a little bit like the earth, with craters, mountains, and all that. And Cigoli did the same. Now, there was another painter that was a good friend of him, which was a woman painter, Artemisia Gentileski, one of the truly great painters of the Renaissance. But by the way, it just so happens that exactly now there is a large exhibit of her at the National Gallery in London, which I wish I could go to, but because of the pandemic, I'm not gonna take the flight. So this is one of the paintings that Artemisia painted of Judith beheading Holofernes. Now, this was her first version of that painting. But then I want to draw your attention to here. She learned from Galileo that projectiles in air move along parabolic orbits. So she painted a second version of this same scene, Judith beheading Holofernes, but in which she painted the blood squirting out of Holofernes' neck. And there it is. Look at this. Following the parabolic orbits, that Galileo told her that it should do. And this was her second version of this same scene. Okay. I don't want to leave you with the impression that Galileo was the nicest person on the surface of the earth. He wasn't. He was very nice to members of his immediate family. He was quite nice to a few of his personal friends. But boy, if you objected to what he said in science or otherwise, he could be vicious. He had a sharp tongue and an even sharper pen. And I just want to give you one example of his attitude. He wrote this book, which called The Essayer, where he had a dispute with a Jesuit mathematician named Grassi, who was actually a famous mathematician and a good one. And they discussed, among the things they discussed was the nature of heat. Like what does physics have to say about heat? And Grassi made the unfortunate mistake from his perspective of relying on a very ancient story that the ancient Babylonians used to cook their eggs by whirling them on slings. That they would put the eggs in a sling and whirl them like very fast, like this. Oh boy, Galileo heard this. In Yiddish, they sometimes say made tzimes of this. He decided to demolish Grassi completely. And he has a whole passage where he writes something like this. He says, the ancient Babylonians cooked their eggs by whirling them on slings. I'm willing to believe that. But let's see, when we do this, the eggs don't cook. In fact, if they were hot to begin with, they will even cool a little bit. So what is it that is different, that why it worked for the Babylonians and it doesn't work for us? Let's see what's going on. So he says, look, they had eggs, we have eggs. They had slings, we have slings. We have also strong guys who can whirl them very, very fast, and yet nothing happens. So what is it that is different? He said, well, the only thing that is different is that they were Babylonians and we are not. So it must be that the eggs cook because they were Babylonians. That was the type of sarcasm he was using. And Pope Urban VIII liked this so much that he had passages from this book read to him at breakfast every day. I'm jumping now a couple of decades to this book, The Dialogue on the Two Chief World Systems. Galileo wanted to write a book supporting the Copernican system, but in 1616, there was an injunction against him that he shouldn't do that. He ignored that, thinking that he can get away with this. And he wrote this book where three people, have a conversation. One of them is sort of a stand-in for Galileo himself, who describes the Copernican system. One is a strong Aristotelian supporter who describes basically the Ptolemaic system. And one is a neutral, intelligent person who listens to the arguments. Now, throughout the entire book, the guy who is the Copernican basically ridicules the Aristotelian guy. But you see, Galileo could not have published this book because, this went against what the church believed. And he had to get permission to publish the book. Every book had to have permission from the church. So he added the preface and the conclusion, which basically negated the entire book. In the preface and the conclusion, he said, oh, well, it is really all, God Almighty can do things however he wants. And so this is all just arguments in this direction and in that direction and so on. But to be honest, anyone who read the book could more or less tell that the preface and the conclusion were added as afterthoughts, because the Aristotelian views are really ridiculed throughout the entire book. So Galileo was put on trial for this. And in the trial, he had a very, very strong and an argument that we can understand extremely well today. He basically argued that the Bible was never intended to be written as a science book. It was intended, he said, for our salvation, not as a science book. And he gave us an example. He said, first of all, it was given to teach us moral behavior, ethics, and so on. But whether or not the sun or the earth move, that has nothing to do with ethics. It's not contrary to ethics. So, it shouldn't contradict. Now, here is the important point. The entire Galileo affair is very often described as if it was a clash between science and religion. It wasn't, and Galileo never saw it as such. It was a clash between, and that's what Galileo explained so clearly, it was a clash between literal interpretations of scripture and scientific findings. Basically, Galileo was arguing that the Bible was not a science book. It was written for common people to understand and help them with their salvation. So that if there was an apparent conflict between a literal interpretation of the biblical text and scientific findings, it means that the interpretation was wrong, and you shouldn't take interpretation literally. He also made the point, for example, that, to argue that the Bible is not a science book, that, look, the planets are not even named in the Bible. So how can this be a science book? And finally, he said the most important thing. He said, I don't think that the same God, was giving us our senses, reason, and intelligence, wanted us to abandon their use. So this was his point. And, today we can fully understand all of this and of course, agree with it. But he didn't succeed, and he was put on trial. There are many paintings of the trial, most of them absolutely wrong. So, for example, this painting shows Galileo sitting in front of the cardinals with lots of people attending. It wasn't like that at all. Here it shows him in front of the cardinals. Even that was wrong. I mean, only at his sentencing, there were 7 cardinals. In fact, during the trial itself, it probably looked something like this. There was the prosecutor, Vincenzo Maculano. There was the guy who read the questions, somebody named Sinceri, and there was a guy named Febe who took notes. That was probably it during the trial itself. What happened, of course, we know. He was found vehemently suspected of heresy and forced to abjure on his knees. Here is the verdict, basically. He said that he was vehemently suspected of heresy. He had to be interrogated on his intention, even with a threat of torture, even though nobody really wanted to torture him. He was almost 70 years old at the time. Could be condemned to imprisonment and all that and so on. Now, to be interrogated on his intention was important. The thing was that they wanted to establish whether, he said what he said by mistake, in which case he was only vehemently suspected of heresy, or he intended to say all that, in which case he would have been found heretical and would have been burnt at the stake, like Giordano Bruno was actually during Galileo's life. So he was basically forced to abjure. He agreed on his knees again. I said, I abjure, curse, and detest all the above mentioned errors and heresies. Basically, he claimed that all his life's work was error and heresies. This remains to this very day one of the most shameful assaults on intellectual freedom. There is no other way of saying this, because even though the church was right in finding him guilty in some sense, because he did disobey this injunction from 17 years earlier, you think about this and you say, let's suppose that Galileo was wrong and the Copernican model was wrong. So what? Why couldn't he still, say it? I mean, why should he be condemned for that? So that's the situation. Of course, Galileo ended up basically giving the finger to the Inquisition when his remains were removed from an obscure grave to the tomb in which they are today. Somebody removed 2 of his fingers, a tooth, and the vertebrae, and all of those are, the vertebrae not, but all, the fingers are in, and here they are. They are in the Galileo Museum in Florence. It took 350 years, but after 350 years, Pope John Paul II said the following: paradoxically, Galileo, a sincere believer, proved himself more perspicacious on this issue than his theological adversaries. They basically did not understand the difference between Holy Scripture and its interpretation. In other words, precisely what Galileo was saying, that he is not against Scripture, he is against literal interpretations. Pope Francis said the same. Here I am with Pope Francis, only it's not the real Pope Francis. It's a cardboard image of Pope Francis, but it looks extremely real. It's at the Catholic University of America in DC, and I couldn't resist the temptation to have this photo taken. But Pope Francis, in any case, also said that the Big Bang does not contradict the act of creating, and evolution, meaning Darwinian evolution, also is not. So again, the point that you shouldn't interpret the Bible literally, that's all. There is no, otherwise there is no contradiction. Now, this finishes what I wanted to tell you about Galileo, but I remind you that my book is called Galileo and the Science Deniers. And one of the main reasons that I wrote this book was because we are unfortunately encountering rampant science denial today. I don't know what exactly is the situation in Canada, but I can tell you what's happening certainly in the US. And I want to mention in particular one thing. I mean, we're encountering science denial when it relates to the COVID-19 pandemic. I'm sure you are aware of that. But I want to mention something else which has to do with climate change. Now, I'm not myself an atmospheric scientist. I'm an astrophysicist. So I want to make things very, very simple and things that everybody can understand, and not to get into details of modeling of atmospheres and things like that. So all I want to show you is, you know that on climate change, well, there are some people who deny that even it exists. And then even those who already agree that maybe there is some climate change, they don't believe that humans have anything to do with it. So I will just show you the carbon dioxide concentration in the Earth's atmosphere. And in the past 50 years, it was measured extraordinarily accurately in Hawaii by a scientist named Keeler, and his son now continues his work. Here you can see even the small daily variations. And I don't even want you to look so much at the numbers of the concentration as to the slope of this curve. So this is in the past 50 years. But you know that we can determine the carbon dioxide concentration also from ice cores. Basically, they dig these columns of ice, like in Antarctica, and just like you look at rings of trees, and you can tell what happened with a tree, you can tell what the carbon dioxide concentration was. So we have, for example, this thing for the past 300 years. And you will notice that, the Industrial Revolution happened sometimes, around 1800 something, and you look at the slope of this curve, of what's happening with this, and especially in recent times. But it's not just that. Look at it for 10,000 years. We can do this with ice cores. And look, it wiggles around a little bit and so on, but look what happens most recently. And believe it or not, they actually have data on CO2 for the past 800,000 years. And some people, even very high up in the US, say, oh, we know that carbon dioxide always fluctuated. Yes, and it did. And you see these fluctuations here over 800,000 years. But look what happens in recent years. So to me, this is fairly convincing because, it doesn't involve any of the details of the modeling. It's just measurements. So I want to finish here and with a lesson from Galileo. This is Galileo's tomb, which is very beautiful. It is in the Basilica of Santa Croce in Florence. Here I am in front of it. His tomb is actually right across from the tomb of artist Michelangelo. And the main lesson that I want us to take from Galileo's lesson is the following. It is really never smart to bet against the judgment of science. And this is not because science is always right. In fact, scientists would be the first to admit that at any given time, science is only as correct as the data that are available at the time. And, science changes as the data changes. The thing is that science has this ability to self-correct, and it continuously self-corrects. Sometimes the self-correction takes a few years, sometimes it may take decades, but it always self-corrects. Now, so it's never a good idea to bet against the judgment of science. Now, in cases when human life is at stake, as in the COVID-19 pandemic case, or when the entire future of the Earth's biosphere is at stake, as in the case of climate change, it is really unconscionable to bet against the science. And that is really the main lesson that we can take from Galileo. So with this, I want to thank you for listening. And I remind you that, there is this book, which I really hope that you will read, because of course there is so much more in the book than what I was able to say here in less than an hour. Thank you. Now,
thank you, Dr. Mario. That was great. So everyone, we've got some time for some questions, and I've got any questions for Dr. Mario. Please. Okay, so Darren has something. We have actually been spoiling the Earth for over 70,000 years.
Come on, Jay's not that old.
Sorry, was it a question or a comment?
I think it was a comment, sorry. So I guess it's kind of a question too. It was asking, just a minute. Darren, did you want to say anything or?
Yes, thank you. Yes, Dr. Livio, I was going to say, I've been recently reading a book on sort of the history of humankind. It's a fairly modern book by an Israeli, he's actually
Yuval Noah Harari.
Yes. Yeah. And he mentions that actually humankind has been affecting the biosphere for like several tens of thousands of years. And there's a lot of archaeological and historical evidence to, suggest this. And I'm not saying that the current state of affairs is any less alarming, but I think it lends more credence given what we're seeing today, and even just that simple series of measurements that you meant. So I guess the question I have for you is, what do you see as sort of the main mandate, given that there are so many science deniers out there, particularly in the US and some other countries too, and even in Canada here we have it. What do you see as the easiest way to kind of steer them in a direction? Because it's really hard to fix stupid.
You hit on a very important point, which is that, there are actually many psychological studies which show that once adults have actually formed an opinion, it is extremely difficult to change that opinion, even when even when they face, facts, before them. So there are only two ways that I can think of where we can address this. And one of them is more immediate, and another is actually much longer term. The one that's more immediate is that the only way to convince people, again, this is psychological studies show this, to convince people is if you bring to them somebody who previously had their opinion and changed their minds because of facts. So for example, you notice that I brought as example two popes because the church had one opinion at Galileo's time, and now two popes have agree with Galileo. So that is much more convincing than if I will come and say, oh, you have to agree with Galileo and not with this. So that's you have to recruit somebody who once had their opinion and changed their mind. They are much more effective. The more long-term answer is that I actually do believe that we have to start with education concerning science with small children from a very, very young age. And by that, I mean not to make everybody a scientist, God forbid. I mean, we absolutely need the humanists and the literature people and the artists and all that. But everybody should have a certain appreciation of what science is all about and how science operates. Everybody should know that there are certain laws of nature, which, as far as we can tell, hold in the entire universe. And that those laws, as far as we can tell, appear not to change. That everything we use today, life expectancy today is about twice what it was in Galileo's time. And that's only because of science. The cell phone that we hold in our hands, first of all, was only built because we know quantum mechanics, but also it uses a GPS system which uses both Einstein's special relativity and general relativity. People may think, what do I have to do with Einstein's relativity? You do. If the GPS system in your phone did not use that, you would be off by a few miles every day. So people need, even if they don't know how to do calculations in GR, they need to understand, what science actually does and how it operates. Any other questions?
Yes. Hi. Is there any other questions?
Thank you, Dr. Livio. Appreciate it.
Okay, thank you, Darren.
It's okay if there aren't any more questions. I mean, don't force people to ask questions. Okay.
Well, I think that's basically it. According to the post here, a lot of people thank you. It's a great presentation, they're saying. Someone wants the last slide of your quote about climate change. I don't know if you want to do that, because everything's recorded so they can see it on YouTube and our website. So we got a lot of feedback here. Everyone's saying thank you very much, Dr. Livio. So if you have any more questions, we will conclude that meeting today. But before I let you go, does anyone else has questions or? Nope. Okay. Before you go, Doctor, we do have a special gift that we give out to our speakers. I don't know if you can see this. It's an actual meteorite.
Oh, very nice.
So if you give me your address, I'll send it to you free of charge.
I'll email that to you.
Okay, perfect. I also email you the Boston Pizza invite. So if you want to join us there, it's a more casual meeting with our members. Of course, we can't go to Boston Pizza because it's COVID-19. So it's just something we came up with, so bring your own beer, bring your own pizza, and then we'll try to socially. All right. So if there's no more questions, we'll conclude our meeting for today. Thank you everyone for joining us. So again, that will conclude our meeting for December 11th, 2020. So stay home and Merry Christmas to everyone. So we'll see you tomorrow at after dark. All right. Thank you, everyone.
Bye-bye.
Bye-bye.